Okay, so we're starting. So, this section's not in your book. This is Trigonometry Review. We're going to start with the basics. The first thing I need to make sure you all know is this is a no calculator unit, which is a good thing for you guys, because that means you're not going to have to figure out trig values for angles where it's all kinds of decimals. The angles that you're going to be dealing with will all be multiples of 30, 45, 60, or 90. Okay? So all of your angles will be from the special right triangles or on the axes. Now, quick review of the special right triangles. Okay, so we have the 30, 60, 90 triangle. The sides of the 30, 60, 90 triangle are x, 2x, and x root 3. But because trig values are ratios, we can pick any one of those triangles that we want, and the ratios will be the same, regardless of the size of the triangle. So as long as the angles are 30, 60, and 90, we can pick any one we want to use for our trig values. So I like to use a triangle where the sides are 1, 2, and root 3. That one is the most helpful for me to figure out my sine, cosine, and tangent functions. All right. We also have the 45, 45, 90 triangle. 1, 1, root 2. From these, you can figure out the trig values for the vast majority of angles that we will be doing in this class. Of course, using your old friend, Sokotoa, right? I could sing the Sokotoa song, but I will do it off camera. There is a Sokotoa song in my math song sing-along book.
No,
well, you might want to look back like 20 years from now and see if you still remember the words, but now you can verify because it'll be on camera, like if you know for sure.
I learned Sokotoa in this classroom 2 years ago, or 4 years ago.
I never learned the song.
No one learned the song.
I remember like in freshman year, like, opposite B, plus or minus squared, plus or minus squared.
That's quadratic
that's
formula.
the quadratic formula song.
Oh, it's just like you'll always remember that.
That was that's extra credit in Miss Mulligan's class.
Really?
Yeah.
Do you know, I liked the Pop Goes the Weasel version better. I think it's a simpler and more direct version of the quadratic formula. But regardless, Sokotoa gets sung to the tune of Oklahoma. So when we shut out the camera, I will sing
just sing it right now.
Nope.
Right now, right now, right now, right now, right now.
Okay. And of course the letters, this is an acronym, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. If you take a look at the handout that I gave you all, right? These are at the top. Okay, so there's your basics of trig ratios. And then, of course, cosecant, secant, and cotangent are those reciprocals, right? So let's just start really simple. Let's see if we can remember how to do sine, cosine, tan, and just for fun, let's do cosecant, secant,
Doesn't secant go with cosine?
and cotangent. Yes, it does, which is why I'm writing them across from their appropriate reciprocal function.
Okay.
Yes. I want you guys in your groups to take 30 seconds. Remember, look at your triangle. If I want the sine of 60, remember opposite, each angle has two sides that make up the angle. The two sides that make up the angle are always the adjacent and the hypotenuse. The side that does not form the angle, that's the opposite. So if I look at 60 and it's made up of these two sides, say I shot an arrow out and hit this third side, that's going to be the opposite side. Hypotenuse is 100% always the longest side of any triangle. It doesn't have to be right. Any triangle, the longest side is the hypotenuse. For a right triangle, it's the one opposite the right angle. So, because the right angle has to be the biggest side, or biggest angle. So, and this has to be the biggest side. So, what you have for 60 is that's your opposite, this side is your adjacent, and then this side is your hypotenuse. So see if you can figure out your 6 trig values. Go.
Do you want radicals in the denominators?
Good question. I will accept either way, but you have to be familiar with both because it could be multiple choice.
Boo.
Do you have to rationalize your denominators or not?
Hey, Nutter, I wrote your red letter yesterday, then I threw it away.
Why would you write a red letter this early?
Yeah, I'm not writing until like the last day of school.
I'm gonna write a red letter at Miss Price.
You don't know what red letters? Davis, get out.
Years ago, I actually wrote an individual red letter to every single senior that I taught.
Why don't you do that now?
I'm not doing it again.
You should write a red letter to me.
Were they meaningful?
They were I did every single student handwritten individual for every.
If I don't get one, I'm gonna cry.
You might be crying. I don't know. What I might do is a little generic red letter to everybody.
But for one special one for me. I'll bring you parchment and you
on
can
yours, I'll put a happy face.
Alright, that'll make me. As long as nobody else has a happy face, I'll feel special.
Okay.
Can I have another face too now?
I'm gonna have 2.
Okay, yeah, Noah and me can have happy faces. Mustafa can have 2 happy faces.
Everybody could get their
He
own
can get like
sticker.
a frowning face.
Ooh, I want to scratch this thing.
Ooh.
Ooh.
We'll
Take
see.
with me.
That's only for the best students.
Okay. Sine of 60 is what?
Root 3 over 2.
Root 3 over 2. And guys, one of the things that you should learn when you're learning, it's real important that you kind of have a pretty solid memorization of your basic angle trig values. So sine and cosine for 30 and 60, you should just kind of know. And you don't have to know them all. If, for example, I know sine 30 is a half, so then, and it's either a half or it's root 3 over 2, right? They just flip-flop. So if I know sine 30 is a half, then I know sine 60 has to be root 3 over 2, because they flip-flop. And then if sine 30 is a half, I know cosine 30 has to be root 3 over 2, so cosine 60 has to be a half. So I kind of, that process goes through my head in a pretty quick way when I'm doing these values. So I know sine 30 is a half, so sine 60 is root 3 over 2. So therefore cosine 60 is a half. Tangent is sine over cosine. So tangent is root 3 over 1. So tangent of 60 is root 3.
I would just done the opposite of you.
Are there questions on any of those? Everyone okay with that? Doing the reciprocals, cosecant is the reciprocal of sine. There are actual valid reasons why the co-function goes with sine and then the original secant function goes with cosine, which we might have time to talk about in the future and we might not. But what I learned it was about 2.5 years ago, I learned why tangent is named tangent and why secant is named secant, and then the co-functions that go along with it.
Okay.
And it's pretty cool. So a tangent is actually a tangent line. It represents a line that's tangent to the unit circle and the angle that's formed. So it really is that it's not a completely separate use of the word tangent, they relate. So same thing with secant. This is actually a value, a length, and that's formed by a secant line with the unit circle. So anyway, and then the co-functions, of course, ever know what co stands for?
Together.
No?
Okay. No.
Together, yeah.
Cooperation.
Cooperation. No, the sine of 60 equals the cosine of 30, right?
Yeah.
And the cosine of 60 equals the sine of 30. The sine of 45 equals the cosine of 45. The sine of 90 equals the cosine of 0. I'm going to take it up a notch and tell you that the sine of 20
complementary.
equals the cosine of 70. These two functions are complementary functions, meaning that when the angles that you're talking about total to 90, their values are equal. So the sine of 40 equals the cosine of 50, right? You're talking about complements. So that this cosine means the complement of sine, right? That's what the co stands for. So because these are complementary functions. All right, so cosecant, the complement of our secant function. So we do sine 60, so we've got to take the reciprocal. You get 2 over root 3. If it was free response, that would be fine. You could just stop. But on a multiple choice, that's obviously not going to be an answer choice, right? So the answer choice that they would give would be 2 root 3 over 3. So you have to be okay with both. right? Secant of 60, what's the reciprocal of a half? Okay, and then cotangent, the reciprocal of tangent, you get 1 over root 3, which we would, of course, root 3 over 3. All right, everyone fairly solid with those?
No.
Good. I am going to move into the unit circle after I bridge the gap and we convert in from degrees, of course, into radians. Because everything in calculus is measured in radians. There are no degree problems that will be given on any quiz or test. Your book presents some problems in degrees, but everything that you see on the AP exam will be in radians. So everything in this class. Radians, poor K. Radians are the natural angle, right? Degrees are man-made, right? We all know why there's 360 degrees.
That one's like the 360 days in a year.
Yeah, exactly, because Babylon thought there were 360 days in a year, 360 days to travel around the sun, so they had each degree is how far you would travel in one day, right?
Close.
Okay, and they were pretty close, but it's not, that is more of a man-made unit of measurement. Radian stands for radial angle, right? A radian stands for radial angle, and a radian, of course, is if you were to take the radius of the circle, so if I took this distance right here and wrapped it around the edge of the circle, however far it would go, the angle formed to there and the x-axis would be 1 radian, right? And then, of course, if you kept going, you would get about 3 and a little extra to get halfway around the circle, right? How many exact radians does it take to get halfway around the circle? It takes pi of them, right? Because pi radii fit halfway around the circle. And then, of course, if you kept going, it would be a little over 6 of them to get all the way around, which means it takes 2 pi to get all the way around the circle, right? So if you took the length of your radius, wrapped it around the edge, and then drew a central angle, that angle formed as a radian, right? Okay, so that's your radial angle, and in this class, the radians that we will refer to will all be multiples of the following angles. Pi 6, pi fourths,
That's not as impressive.
pi thirds, pi halves, or pi.
You know there are Olympic or world championships for drawing circles? Have you ever seen that?
I have not actually seen the World Championship, but I do know that there are contests
It's
of that
insane.
nature.
Like they just start here and they do it and it's just all the way around their rotator cuff type deal. It's pretty intense.
I feel like it would be hard to draw a perfect circle.
Yeah, I know it is.
Yeah.
I think you should participate because that was a pretty good circle.
Okay, we'll think about it. So pi over 6, did I know how many degrees this angle equals to?
30.
30 degrees.
Because 180 divided by 6.
Beautiful.
Thank you. I know.
Yes, because pi is 180, right, in degrees, and you get 180 over 6 is 30, right? You can just think 6 times 30 is 180, right? What's 180 over 4? 45, 60, 90, and of course 180. Radians are easier to use than degrees. It's an adjustment that you have to kind of get your brain used to, but once you're used to it, they're very easy to use. And the reason they're easy to use is for when you get into angles that are outside of the first quadrant, right? If I said, hey, what's the sine of 225, right? You'd have to think for a minute to figure out what is the reference angle, where is 225, I'd have to, is it close to x-axis 180, I gotta subtract, okay, it's 45 degrees, right? For my reference angle. Whereas if I said, hey, 5 pi fourths, you know pi fourths is the reference angle, you know it's a 45, right? So you don't even have to think about it, you just look at the denominator and you've got the reference angle. So there's no subtraction, no addition, no which quadrant, that kind of stuff. It's very straightforward. So very quickly, I'm going to I'm going to have you guys do the 6 trig functions again. Let's do a higher radian angle, but I don't want you to fill in the signs yet, just the numeric values. So how about we do, let's see, we've already done a 60. You want to do a 30 or a 45?
Let's do a 45.
45, so how about 5 pi fourths?
What did you do with the first period?
Honestly, I just don't remember.
Because they're not important.
Oh,
Yeah, you heard me first period.
Do you like choosing art class or first period?
Obviously ours, that's why she
Do
records
you have a
us.
different personality than first period as a
I heard you do. I heard you're not as in control in first period.
I'm not aware of that.
What about fifth period?
They got some hood.
There are rumors, you know.
Something tells me that you have a different personality first period than you do now.
No, I don't.
No, you don't.
Oh, really?
I get annoyinger throughout the day.
Annoyinger?
I get more annoying. I just have the
Okay.
same amount of energy all the time. I never
Okay.
decrease or increase.
Ah, well, that's good.
So that was
I
That's
talk in my
consistency
sleep,
is
too.
good. Okay, here's what I want you to do. I want you to find the values of the 6 trig functions
Because I
for, what is the reference angle for 5 pi fourths?
Pi over 4.
Pi over 4, or in degrees, 45 degrees, right? So you can use your 45, 45, 90 triangle.
Oh, now you gotta do all students.
No, yeah, but not yet, not yet. It's okay. So, and just figure out the numeric values for these 6 trig functions. No positives or negatives, just the numbers themselves. And then we'll do the positives or negatives in a
Root 2
moment.
over 2.
So everyone do it. Take a moment.
Okay, sine of 45.
Root 2 over 2.
How do you know it?
Same for cosine. Root 2 over root 2, 2 over root 2 is 2 root 2 over 2. Just root 2.
Wait, what was it for 2 minutes? Opposite over adjacent, isn't that 1?
Yeah.
Positive.
She said not to worry about the signs and stuff.
I wasn't worried about them. Oh my god. Oh my god.
Okay, sine of 5 pi fourths, there's 2 ways to write it. If the non-rationalized form would be 1 over root 2, right? And then of course to rationalize that you get
Root
root 2 over 2. Now you have to be familiar with both. Both of these will come up from time to time. So, and the reason I keep saying you be familiar is because you might have an equation like sine x equals 1 over root 2. And then you need to be able to figure out what angle that is, that kind of stuff. So you need to be able to be familiar with both. All right, cosine, same thing. Tan is sine over cosine, so what's tangent? 1. The reciprocal, it's actually easier to reciprocate this one than this one, right?
Yeah.
So what's the reciprocal of 1 over root 2? Root 2. Root 2. And what's the reciprocal of 1? 1. Good.
1.
These are the numeric values for any angle where it's radian and the denominator is 4. Right? Does that make sense? Okay. The only difference are the signs, the positives and negatives, right? How do we figure out the positives and negatives? That's where we make our circle. Our circle. All students take calculus.
All
Right?
strippers take cash.
All strippers take cash.
Just wanted to have it on record.
Do they all take cash? Okay.
Some probably take credit cards.
Man, I'm sure they
Okay.
take cash.
Maybe the high end
Money order, check, patient.
All right. All strippers take cash.
In Russia, they take vodka.
All right. Now what that tells you is it tells you which function is positive in that quadrant. All of the trig functions are positive in the first quadrant. Sine is positive in the second. Tangent is positive in the third. Cosine is positive in the fourth. If it's not positive, it's negative. So if sine is positive in the second quadrant, cosine and tangent are both negative. All right? If cosine's positive in the fourth quadrant, sine and tangent are both negative. Okay? Another way to think of the positives and negatives is to remember that your sine is your y value. On the unit circle, it's the y value of an ordered pair. So if you think of that, the sine would be positive whenever the y value is positive, which is above the x-axis, and negative anywhere below the x-axis. Cosine is your x value, so it's positive whenever x is positive, and it's negative wherever x is negative. I like to think psi y co ho, because sine goes with my y, right? Cosine goes with my horizontal component, right?
That is not at all right. I'm sorry, that's not at all what I thought.
Oh, well,
I'm sorry.
that's what it meant. So,
Sine goes.
psi y co ho. So sine is your y, cosine is your x. All right. So anyways, if you want to think of that, or you just remember all students take calculus, and then you're good. So based on this, now how do we know which quadrant we're in? There's a couple little tricks to remember which quadrant you're in. The easiest way to figure it out is to know over here, this is 0, this right here is pi, and if you kept going around, remember we go counterclockwise unless the angle is negative, and then we go clockwise, right? So we always go this way. If we're going in this direction, this angle is 2 pi, right? If we're in fourths, think of pi as 4 pi fourths. And then 2 pi would be
8 pi.
8 pi fourths, right? So if I have 3 pi fourths, I'm here.
Right.
5 pi fourths, I'm here. 7 pi fourths, I'm here. 1 pi fourth, I'm up here, right? All the single pi over whatever is in the first quadrant. So, does that make sense?
Yeah.
Okay, so we're at 5 pi fourths, so here's 4 pi fourths, we're in the third quadrant. Which function is positive in the third quadrant?
Tangent.
Tangent, which means sine and cosine
We're both negative.
are both negative. If a function is negative, then its reciprocals are also negative. Like, how do I do this? Oh yeah. My camera keeps drifting down.
Because Nelson keeps fidgeting.
There we go. All right. Its reciprocals are also negative, so that's negative and that's negative. Does that make sense? Y'all okay with that? Good. Don't worry, you're gonna do lots and lots more. Woo-hoo. Okay. Good. Axes. Let's talk axes.
No. No.
It's very important that you know the angles, the trig values on the axes.
It's like 110.
They don't get emphasized as much as they should. And the reason that they come up a lot in this class is, of course, if you have to find where your derivative is 0, say you're doing a curve sketching trig problem, and you find the derivative and you set it equal to 0, it's real important that you know where sine is 0, where cosine is 0, where tangent is 0, right? You have to know those, and those are always on the axes, right? So you got to know the trig function values at all of your axes. How do you determine the trig function values at the axes? All right. Going back to the unit circle. What is the radius of the unit circle?
1.
1. That's why it's called the unit circle, right? So if we were to write this point as an ordered pair, what would the ordered pair be?
1 0.
1 0.
She told me to be quiet.
This point up here would be what?
0, 1.
0 1. And that connects nicely. All right. Over here,
Negative 1, 0.
negative 1 0. And down here,
0, negative 1.
0 negative 1. So let's say I asked you for all 6 trig values at 3 pi halves. By the way, every trig function has to have an input. It has to have an angle plugged in, right? You would never write a trig function with no angle associated. It wouldn't make any sense. So make sure you always write that angle, or if it's a variable, write the variable. Don't just write SIN. Oops, go to
Stuff that you.
Okay, again, this goes to psi y coho. Sine is your y value, cosine is your x value. Cosine is your horizontal, sine is your vertical. So, if I were to go to 3 pi halves, where is 3 pi halves?
3 pi halves.
It's at the bottom, right? This is 0, this is pi, right? Up at the top is pi halves, down at the bottom is 3 pi halves. So I go to the bottom, I look at my ordered pair, my x is 0, my y is -1. Sine is the y, so sine is -1. Cosine is the x, so cosine is 0. Everything after that you figure out from sine and cosine. Tangent is sine divided by cosine. What is -1 divided by 0? Undefined. Now we do the reciprocals. What's the reciprocal of -1? It's -1. What's the reciprocal of 0? Undefined. So, undefined. Now, be careful, what's the reciprocal of undefined?
0.
It's 0. And the way you can think of it is if tangent is sine over cosine, cotangent is cosine over sine. So tangent is -1 over 0, cotangent is 0 over -1. Whenever you're in this class, just think the reciprocal of undefined is 0. Okay? The reciprocal of 0 is undefined.
IOU and IUO, like a different way of
that's
sentence,
cute.
sentence structure.
Okay. All right. Good. All right, so take a look at the review sheet that I gave you for a moment. So now it's up too high.
Different ways of saying the same sentence.
All right. Let's talk identities.
Like the Born identities? Maybe. It's a great try. What about the Born supremacy?
The identities that are on that sheet are the only identities that you have to know. And you do have to know them.
But it's Friday.
And now is as good a time as any to start relearning them. The first identity that you have to know, of course, is the Mac Daddy of all identities, the Pythagorean sine squared plus cosine squared equals 1. That's like the most important. If you don't know any other identities, know that one, right? Now, how can I derive the other two Pythagorean identities from this one?
Divide them by sine squared x for the cosecant, and then sine or cosine squared x for the.
See, you had a great pre-calculation, right?
Miss Wilcher also taught us that. Shout out to Miss Wilcher.
Yeah, way to go, Miss Wilcher. Okay, so yes, if you divide every term by sine squared,
Ew.
Bro, ankle socks are the way to go.
sine squared over sine squared is 1. What's cosine squared over sine squared?
Cotangent.
Cotangent squared. What's 1 over sine squared?
Cosecant.
Cosecant squared. Right? So you divide everything by sine squared, and that gives you one of the Pythagoreans. And then, of course, to get the other one, you divide everything by cosine squared. Sine squared over cosine squared is tan squared. That's right. Good. Cosine squared over cosine squared is 1, and then 1 over cosine squared is secant squared. Right? And there's your 3 Pythagoreans. So you need to know all 3. They will come up mostly in equations. You're going to have a lot of trig equations to solve.
Do you wear ankle socks when you wear tennis shoes? Like socks that like stop at your ankle, or do you wear the socks that like go up?
I wear ankle socks.
Yeah.
Very, very important question, yes.
So Miss Price is cool. You guys are just weird.
I can't wear the socks, so you know those ones that are like low, like below? They make those
like
really
the
low
women's
ones.
socks?
Yeah, I always feel like they're gonna scooch down under my heel. So I have to wear true ankle, but I don't go above.
Yeah, see, these guys all wear like above ankle socks.
Oh, but they're guys though, it's different. It's probably different for guys and girls, right?
But I wear ankle socks. Why would you say that? Neither
Your socks are fire.
Alright,
girls like it when you're in touch with your feminine side.
the other identities you need to know are the double angle for sine and cosine. The double angle for sine, and I am doing a shout out to my old student Arabella.
What's her last name?
I'm not gonna say her last name.
Portugal or Spain.
I don't know, I don't have permission to use her name on the tape, so I'm just gonna say her name was Arabella.
Right
Okay.
Can we call her Arabella X?
Okay, so Arabella, if you ever watch this video, which you never will, but you never know. Anyway, I'm about to sing your song on tape, which I really don't want to. Okay, here we go, and I'm gonna do it with joy and fervor, okay?
Yeah.
So this is the song I had years ago when I taught pre-calc. This was back at Riverwood High School. I had all of my kids write a song to help them remember all the different identities. And so this Arabella was so excited, she literally ran into class, ran right up to the front and just jumped right in and started singing in front of everybody. Okay? Here we go. Sine 2 theta is 2 sine theta, cosine theta, 2 sine theta, cosine, woo, woo. So there you go. And then you can do it again.
Repeat that?
I'm not gonna remember.
Sine 2 theta is 2 sine theta, cosine theta, 2 sine theta, cosine, woo, woo.
I think it'd just be easy to memorize.
Yeah.
Okay.
I'm gonna be honest. That was extremely
Okay.
hard.
So anyway, this is a dangerous identity. It's an easy one to learn. Sine 2 theta is 2 sine theta, cosine theta. But here's how the College Board will get you. You will work a derivative, and there's a real common derivative that actually ends up looking just like this. So say like you're doing a derivative and you end up with the answer of, oh, how about 2 sine pi 6 cosine pi 6. And it's multiple choice, and you don't see this on any of the choices. But let's say just for the heck of it, like one of the choices is this. And then you're going to be like, oh my goodness, I don't know what to do, I don't know what to do. Should I pick that? It's the closest one to what I have, right? Okay, of course one of the other choices would be that. Right? So you've got that with the 2 in front of it on your paper. You see this and this, and you're like, most students are going to go for that, right? Because it's the closest to what they see. They're not going to think double angle identity for sine, oh, I need to convert this to this one. And that's a way that they get you, right? So be very careful, because they love to do that in the multiple choice, is use identities to convert answers. So just be very aware, okay? That's all I'm saying. All right, cosine 2 theta. I like x better than, I really don't care. It's faster to say x. So I use x when I'm writing, it's just faster. So cosine 2x, there's 3 of them. The first one is cosine squared minus sine squared. If you know this, you can get the other 2 pretty simply by just plugging in a little conversion. If you know, I'm going to back this up a little bit. If you know the Pythagorean identity that sine squared plus cosine squared equals 1, then you know that sine squared equals 1 minus cosine squared, just by subtracting, right? So what you do is you replace your sine squared with a 1 minus cosine squared, and you end up with 2 cosine squared minus what? If you replace the cosine squared with a 1 minus sine squared, then you get 1 minus 2 sine squared. Right? It's nice to have 3 different ones because if you're using it while you're solving an equation, each one comes in handy at different times. If your equation is all sines, then of course you'd want to use the one to convert it to be a sine, right? If the equation is all in terms of cosines, you want to use the cosine one. If it's a mix, then you just use the mix. It just depends. Usually you're using one of these 2 though. Okay, so anyway, so that's it for identities. That's all you have to know. There's no verifying identities in here. It's not a pre-calc test, but you use these a lot in the context of calculus. When you're it's mostly in the context of solving equations. All right, one more quick thing, and then we'll get into the equations because that's the biggest part. Or, well, you'll have a lot of it in your homework, but it's an important part that I want to get to today. If we don't get to it today, don't worry, it won't go away. But equation solving with trig is going to come up more than anything else.
Is there, because we have to normalize formulas, does the AP exam have a formula sheet?
Nope. No formula sheet for calculus.
Wow, that's horrible.
Okay. If y equals a sine bx plus c plus d. There have been questions on the AP exam that were straight up pre-calc questions saying, hey, what's the period and amplitude for this function, right? So you do have to know period, amplitude, phase shift, and vertical shift, just in case it gets asked. I will tell you personally, the formula for the phase shift is dependent on where this b is located. So if the b is in the parenthesis, or if the b is outside the parenthesis, it's 2 different, it's really the same formula, but what you have to recognize is if I factor it out, if I pull the b out, I get that, right? The phase shift is always the number that's being added to the x inside of here if there's no coefficient on the x. If there's a coefficient on the x, factor it out, pull it out, or divide it to get that phase shift. So just know that b, if the b is inside the parenthesis, personally I always just kind of pull it out, I factor it out, and then I know that's my phase shift. Some people just learn that it's c over b. But the problem is if the b is out here, it's not. It's whatever number is here. So just be careful. All right, so anyway, amplitude. What's formula for amplitude for either of these? It's absolute A. Right? Absolute value of A.
Bruh.
Period.
So,
Full savage.
Oh,
or JK. I thought that it had the period is equal to the absolute value. I was just reading it wrong.
okay. Okay, 2 pi over b. Did I put absolute value b on there? Yeah. So, amplitude, by the way, you don't have to know this. You're not going to use period, amplitude, phase shift, vertical shift to graph trig functions. You're going to be using derivatives, relative extrema, increasing, decreasing, second derivatives, concavity points of inflection to graph trig functions, right?
Yeah.
So you'll be doing curve sketching with trig in the context of calculus. You just need to know these in case they come up on a pre-calc kind of a question. So anyway, amplitude is how high and low the function goes from the center, right, from its central line. So it's how tall the hills and valleys are, right? Period is how long it takes the function to complete one full cycle, right? So it's the size of each individual curve cycle. All right, phase shift.
It's like a circadian rhythm.
I'm getting my erasing stuff.
Yeah, your phase shift is C over B. Here's the thing though, it depends. Like if I write this like this, your phase shift is C over B if it's written, if B is in the parentheses, if B is in the parentheses, and it's C if B is out of the parentheses. So if B is on the outside, it's just this C. If B is on the inside, it's C over B. By the way, phase shift is how much the function's been shifted left or right, horizontally. And I don't know if you remember this or not, for any horizontal translation, you kind of go like the opposite of what you think, right? So even if I have like x plus 5 squared, it's shifted 5 to the left, right? X minus 5 squared would be 5 to the right. Right? Same thing here. This is opposite direction. So if if this is positive, it's a left shift. If this is negative, it's a right shift. Alright, and then vertical shift is just D. Up or down. Positive up, negative down. So it's the same as any other function, it's just applied to trig. They just have special names. Alright, that's enough of that. Now it's time to move into equations. Keep picking up my bad marker, and this is over here, so I stopped picking it up. Alright, let's start simple.
Who's actually gonna pay? Why don't you just throw it out? Your bad marker.
Because it still works somewhat, you know.
I'm already on the 3rd page of notes.
I'm still on the back of my first.
Still in front of my first.
I don't think I used
Alright, we're going to start with a nice, simple, clean one, all axis angles, and then we'll move from there.
Solve.
Okay. So we're going to do sine x cosine x minus sine x equals 0.
Sine x, cosine x.
I had to write this on 3 of the tests from yesterday for first period, which the thing I had to write was you never ever divide out a variable. You would never move the sign over and divide both sides by sine. Ever. Because then you lose those solutions, right?
Was it a bad algebra?
That's what I would have
No,
done
it's
exactly.
just, it is, but I just took off a couple of points. So.
It was like
Yesterday's
stupid.
You never ever divide out a variable. You factor.
Wait, did you say you wrote that on first period test?
Yeah, I haven't graded yours yet.
Well,
It was gonna be the worst.
Anyway, here we go. So we factor a sine. And so we get sine x equals 0, cosine x equals 1.
Oh, I would have done that probably.
Every little like trig equation where you have a trig function equals a number, when you're talking about sine or cosine, every single trig function has 2 answers. Every trig equation has 2 answers. The only exception to this are when sine or cosine equal 1 or negative 1. Because those each just appear at one axis angle. All the other angles on the unit circle happen twice. Each trig value happens twice, right? Okay, sine x equals 0. This is an axis angle. This is where the y value is 0. And by the way, all of these, there's no like 2k pi kind of stuff. Think of all of these as where we have, let's go like this, all right, 0 less than or equal to x less than 2 pi. That is usually the interval we're talking about. So we're just talking about angles between 0 and 2 pi.
So
So-
0 and pi.
0 and pi, right? Where the y value is 0 would be 0 and pi. Now this one actually ends up being a redundant equation, but anyway, where is the cosine equal to 1?
0.
Just 0.
Just 0.
Because, and not 2 pi, because it's not 2.
Right, just 0. Because not at pi, because it's negative 1 there, right? Okay, so tonight, did I give you your homework yet?
Yeah.
No?
It's on the back
Okay.
of the worksheet, isn't it?
No, it's not. Those